Hello everyone, and welcome to another Advanced Higher Maths differentiation video lesson. Today what we're going to do is take a little look at how to understand what the quotient rule is and how to apply it. The quotient rule is quite similar to the product rule, but it's used for a slightly different format of the function, so we'll take a wee look at that. Therefore, the success criteria is more or less the same as it was for the product rule. Understand when to apply the quotient rule, so be able to recognise the types of functions that you should use the quotient rule for to differentiate it. And then the next 3 bullet points are the same. Prepare the process by listing all 4 parts of the rule, write out the derivative using the standard rule, and then simplify the answer as far as possible. I know that some of you were having a bit of difficulty with the simplification part of things. Just keep at it. You will eventually get there with it, I promise. You'll just have to see how you get on. Keep emailing me if you need help. So let's take a wee look. So the quotient rule is used when we have one function divided by another function. So basically functions in the format of this, right? So if u and v are functions of x and y equals u over v, then the quotient rule is, so we can have dy by dx equals v du by dx minus u dv by dx all over v squared. And again, just like the product rule, you have to learn it. There is a shorthand way of writing this out. Again, as there was with the product rule, we can say dy by dx equals vu dash, take away u v dashed all over v squared. And that can be the preferred way of writing it, to that avoids having to write du by dx's and dv by dx's. So if you get that written out like that. There's also a common mistake tends to happen, and you need to be kind of crystal clear on this right from the outset. The numerator there looks very similar to the product rule, but it's not. Okay, it's not. It is different. The order is different, and obviously with the subtraction sign being different, you need to be very careful when you're substituting into the quotient rule. It's quite a common early mistake for folk to think that the numerator for this rule is the same as it is for the product rule. It's not. Okay. Let's maybe look at an example. So we've got differentiate y equals x to the power 4 over 2x plus 1. So there's our two functions of x. U is equal to x to the power 4. V is equal to 2x plus 1. And that is the start of our preparing the process by listing all 4 parts. U dashed is the derivative of u, so 4x cubed. V dashed is 2, and v squared, it's always helpful just to write that out sometimes, is 2x plus 1 squared. That last bit, writing out v squared, is not essential. You should be writing the first 4. If you prefer to have v squared written just to help you out, then go for it. Sometimes it's helpful with some functions to have v squared written out, and then you can simplify it and work with it before you sub it into the rule. So our derivative then, dy by dx. So you'll remember with the product rule, I sort of gave you, and it was nice to see a lot of you using it. I gave you a sort of an idea that you sort of work left to right going across. So you went uv dashed plus vu dashed, and you went like that. You can still do that, but you have to do it in a slightly different order. And actually, the fact that they are different helps you remember them. Just get rid of them. Yeah. Now, the order is slightly different because instead of going top left, bottom right, we're going to start top right, go bottom left. Vu dashed. Okay, so that's 4x cubed times 2x plus 1. take away uv dashed, so 2x to the power 4. And that's why that highlights again that the numerator is not the same. Okay, 2x plus 1 all squared. So as I say, that highlights that the numerator is not the same as it is for the product rule. You'd have to start on the opposite side, top right, bottom left. Okay, so use that process to help you remember the difference between the product rule and the quotient rule. And then what you need to do is just tidy. Usually it's just the numerator you need to tidy up. Very rarely does it cancel down with the denominator, although it might do for certain trig functions. So let's just have a wee look. We've got multiplying out the brackets, we've got 8x to the power of 4 plus 4x cubed. Take away 2x to the power of 4 all over 2x plus 1 squared. Tidy the numerator up again, we'll get 6x to the power of 4 plus 4x cubed over 2x plus 1 squared. There's probably no need to factorise the numerator, you know, unless you thought that factorising the numerator was going to give you a 2x plus 1 bracket, which it doesn't, by which case you almost certainly would, because that would simplify the fraction. But in this case it doesn't, so you probably don't need to take it to the next stage. But if you did, or the answers did that you were looking at, then it's no big deal. So long as you've collected all the like terms, that would be a minimum. Let's have a look at another one. This time it's x cubed over sine x. So again, same process, u equals x cubed, v equals sine x, u dashed equals 3x squared, v dashed equals the derivative of sine x, so that's cos x. And so v squared is going to be the sine of x squared, so sine squared x. Put it all together and get the derivative. Dy by dx is vu dashed, so that's 3x squared sine x. Take away uv dashed, x cubed cos x, all over sine squared x. Okay, now with the numerator here, there's no like terms to gather, but we can factorise it, so we'll factorise this one, and it's going to be a common factor of x squared. X squared comes out, and we get 3 sine x, take away x cos x, all over sine squared x. Job done. So that's the quotient rule, folks. It's not overly complicated. I mean, as you've seen with the very hard product rule example that I did, this can get tricky if your functions for u and v involve having to use a chain rule to differentiate, or indeed the product rule to differentiate. So you might come across ones like that in the textbook exercise. Be patient. Let me know if you want the solutions. I'll send you them over. What else was I going to say as well? Oh yeah, some folk. I've been talking to some of you over the last week, and you know, there's a lot of some of these exercises are quite big, and they do take a long time to get through. I'm honestly not precious about you doing every question. Obviously, if you try to balance your time, you know, some of you were saying you were getting way more work for maths than you are for some of the other subjects. That's fine. I don't mind that. But if genuinely, if you are struggling, make sure you do at least a few from every question. You know what these math textbook exercises are like by now. They start off nice and easy. They get harder as you go. Each question tends to look at something different. So if you did the first couple and the last couple from each question through the exercise, then you should go on okay. This textbook has little blue stars beside certain questions. You should absolutely make sure you do them. They are key questions for the chapter, and you'll be able to look back through the key questions at the end of the unit and things like that. So make sure you do the key questions, the ones with the little blue stars, and then after that you can pick. And of course, if you want to do the whole exercise, go for it. So thanks very much, folks, and have a good week.